All right, this is our walkthrough for the homework assignment titled Limits and Continuity Extra Practice. So we're going to start off real easy here for the first few, and then we'll get progressively more difficult. So if we want the limit as x approaches 3 of x squared plus 2, just plug it in. Right? 3 squared plus 2, which is 9 plus 2, so it's just 11. The limit as x approaches 100 of 7, that's the limit of a constant. And the rule is the limit of a constant is just the constant. Here we just want to plug in the 5 and see what we get. Well, 5 plus 2 is 7, and 5 minus 4 is 1. So the answer is just 7. Now is where they start to get slightly more difficult. When I plug in the 2, we get 4 minus 4, which is 0, over 2 minus 2, which is also 0. So this is an indeterminate limit. And so we need to, in this case, factor the top and the bottom into x plus 2 and x minus 2 using a difference of squares so that we can cancel the x minus 2 in the numerator with the x minus 2 in the denominator. And it's okay to do that as long as x isn't 2, which it's not, it's just approaching 2. So this becomes the limit as x approaches 2 of x plus 2, which is, of course, 2 plus 2, or 4. If we plug in 1 to our numerator here, we get 1 minus 1, which is 0. And if we plug it into our denominator, we get 2 plus 5, which is 7, minus 7, which is also 0. So again, this is an indeterminate limit. And when we've got polynomials, we for sure just want to factor. Well, the top factors really easily. We can just factor out the x. But the bottom might be a little more difficult for us to figure out how to factor. But what we want to remember here is that if x is approaching 1, that denominator equals 0, which means that x minus 1 should be a factor in that denominator. So I just need to then build in what gives me 2x squared plus 5x minus 7 as the other factor. So that's going to be a 2x and a positive 7. And what you want to do is you do want to just confirm that when you do that, right, you get 7x and negative 2x gives me the 5x that I was looking for here. So the x minus 1s will now cancel. It's a limit as x approaches 1 of x over 2x plus 7, which is now just 1 over 2 plus 7, or 9. 1/9. For our next one here, we've got a couple different methods we could use to deal with this limit, which happens to be 0 over 0, right? 4 squared is 16, and 16 minus 16 is 0. And the square root of 4 is 2, and 2 minus 2 is 0. But I think the easiest way is to just factor out that numerator, right? So this is a limit as z approaches 4 of z plus 4 and z minus 4 over root z minus 2. And we may look like we're kind of stuck here, but we can treat z minus 4 as a difference of squares, right? It's just root z squared minus 2 squared. And so I can continue to factor this as a limit as z approaches 4 of now z plus 4 and root z plus 2 times root z minus 2, all over root z minus 2. And of course, now I can cancel out the root z minus 2's, leaving me with just the limit as z approaches 4 of z plus 4 times root z plus 2. And of course, that's just 4 plus 4, which is 8, times root 4, which is 2, plus 2. So 8 times 4, which gives us 32. This next one, we're going to do the exact same thing, right? Because if I plug in 25 to this, I get 0 over 0. But I can factor the x minus 25 as if it was a difference of squares, right? The numerator is going to stay the same, but the denominator is going to become root x plus 5 and root x minus 5. allowing me to cancel out the root x minus 5 terms, giving me the limit as x approaches 25 of 1 over root x plus 5, which is just 1 over 5 plus 5, or 1/10. This next one here is just a quick insight into our next unit, right, where we're going to treat h as the variable, and the x's are just some other variable or some constant. We could think of them either way. And so if I want to try to find this limit, well, what I'm going to want to do is I'm just going to want to expand out that numerator. I'm going to get a limit as h approaches 0 of x squared plus 2xh plus h squared minus the x squared all over h. And we should be able to see that the terms without the h's in them, the x squareds, should cancel. So we now have a limit as h approaches 0 of 2xh plus h squared over h. Well, we can look at this two different ways. Either we can factor an h out of the numerator to cancel with the h that's in the denominator, or we can just term by term divide each thing by the h. So if we do that, we get a limit as h approaches 0 of 2xh divided by h is just 2x, and h squared divided by h is just h. Well, as h goes to 0, we just end up getting 2x, because the h term is 0. And that's our final answer. For number 9 here, this looks like one that we're going to want to try and factor to solve, but you should always try to plug in the a value first. You get -6 over 4 plus 4 minus 8, or -6 over 0. Well, -6 divided by 0 is undefined, right? So this limit does not exist. Now, if you'd gone through and factored it, you would have seen that you still get -6 over 0, and nothing would have canceled out. All right, for our next one here, we're going to be looking for the limits as x approaches a from the left and the right, and then for the two-sided limit as well. So we'll start with the limit as x approaches a from the left. So as x approaches -5 from the left, that means that x is less than -5. Right? If x is less than -5, that means that x plus 5 is less than 0. So when we do this limit, the limit as x approaches -5 from the left of f of x, we want to try and clear out that absolute value. Right? And so we should remember that the definition of absolute value says if the thing you're taking the absolute value of is negative, which is what we've got here, then the absolute value is just the opposite of what's inside of it. So this should equal the limit as x approaches -5 from the left of x plus 5 over the opposite of x plus 5, which is just the limit as x approaches -5 from the left of 1 over -1, which is a constant, so it's just a constant. For the second part here, as we do the limit as x approaches -5 from the right of f of x, well, now if x is approaching -5 from the right, x is greater than -5, or x plus 5 is greater than 0, which tells us that the absolute value of x plus 5 is just x plus 5. So this becomes the limit as x approaches -5 from the right of just x plus 5 over x plus